Hello everyone. So today we are going to perform another packet tracer activity that is 5.2.1.7, and in this we will examine the ARP request address resolution protocol. So this one is the given topology in the activity, and if I open the packet tracer lab with the new user, okay, so this one is the requirements. Okay, so we have our addressing table, so it's already configured. If we go to the objectives, so we have total 3 parts to complete. The first part is examine the ARP request. So if we start with the step 1, so it is asking to click on the computer that has the IP address 172.16.31.2. So this one is the right computer. Just click on that. Okay, now open the command prompt. So we will go into the desktop, and this one is a command prompt. Click on that, and we have to enter the command ARP-T to create the existing ARP table. So ARP space -T. Okay, the next one is enter the simulation mode. So we will click on here. Now go back to the computer, and we have to ping the IP address .31.3. Okay, so ping space 172.16.31.3. Hit enter. Okay, two PDU will be pairs. Okay, we see two PDU here. The one is the ICMP. So this one is the ICMP, and the other one is the ARP packet. This one is the ARP PDU. Okay, so we see two PDU. Now click on the capture and forward once the ARP PDU moves to the switch 1. Okay, so this one is the forward button. So just click on that. Now our PDU is at the switch 1, and so this one is the question actually. If I open the file, so we are here. Okay, open the PDU and record the destination MAC address. Is the address listed in the table? Okay, the answer is no. Okay, let's check the ARP tables. Just click on this PDU, and if we go and we check the destination MAC address, so this one is actually the MAC address starting all apps. So, and if we check the table, so we don't have any entry of the MAC address that is all F. So the answer is no. Okay, the E part, click on the capture forward button one more time, and how many copies of PDU did switch 1 makes? So if we go and click on the forward button again. Okay, now we see 3 PDUs that are generated. One is going to the router 1, other on this computer number 4, and other one is on the row 3. So the answer is 3. Okay, the next part, what is the IP address that device that accept the PDU? Okay, if we see the output, so we see the cross on this computer and on this router. So only one device accepts this PDU, that is 172.16.31.3. So we will just type the answer of this IP address of this computer. Okay, one, open the PDU and examine the layer 2. What happened to the source and destination MAC address? So this FFL will be turned into the MAC address of this computer, the actual computer MAC address of 3. If we open the PDU over here, and if we go to the outbound layer and layer 2, okay, now this one is the MAC address that turned into the source IP address of this computer to the destination IP of 31.3. if we see the outbound PDU, so we can see the destination MAC address of this one 000C and ends with the ASN1. Okay, H part, click on the capture forward until the PDU return to this computer. How many copies of the PDU switch made during the upper play? So we will click on here. One more time. Okay, now this PDU is received on this computer. So we can see the good mark, and the number of packets received is only one. So the answer will be 1. Okay, now step number 2, examine the ARP table. So in this, open the ICMP package repairs. Yes, we see this one is the ICMP packet. This one, and open the PDU, examine the MAC address table, and do your MAC address source and destination align their IP addresses. So we can check. Just click on this. And if we see the layer 2 header, now we can see the source and destination MAC addresses. Now we don't see any FFF, the broadcast MAC address. So now we have the actual MAC addresses here, source and destination MAC address. Okay, so the answer will be the yes. Now switch back to the real time. So we will go into the packet tracer and just click on this real time button again. Okay, the next one is on going to this computer and type the R-A command, and we will go into this computer. Now type the R-A. Okay, the question is to what IP address does the MAC address entry corresponds? So the MAC address is row 3, this one. Okay, we will type this IP address. The next one, in general, when does an end device issue the ARP request? When it does not know the receiver's MAC address. So when the device does not know the MAC address of the destination, so that source device generate the ARP request to check the MAC address. Okay, now if we move to the part number 2, examine the switch MAC address table. So in the step 1, we will go into this computer and we will type the command ping 172.16.31.4. So go back to this computer. Okay, so this one is the address ping 172.16.31.4. Okay, we are getting the reply. Now go to this computer 10.10.10.2. This one. Go to the command prompt. So we will go to the desktop. And this one is the command prompt. Now ping to the address of number 3. So ping and .10.10.3. Okay, the question is how many replies for send and receive. So for send and for receive, we see 1, 2, 3, and 4 packets are sent and 4 are received. We can also check the number of packets from here. So 4 sends, 4 receives, 0% loss. Okay, now the step number 4. Sorry, step number 2. Examine the MAC address table on the switches. So click on the switch 1, go to the CLI tab and issue this command show MAC address table. table. Okay, we will go into the switch. It's the switch one. This one is the switch one. Go to the select tab and enter the command show MAC address table. So we will go into the enable mode first, then show MAC address table. Okay, we see multiple entries, so source MAC address and the port numbers. So we see the entries. The answer is the yes. If we check the table, this one, so we have the entries, and if we check this MAC address is 75 A7 49 is the A7 49 75. So we have the entries on the switch. So the answer is yes. Okay, we just complete the step 2 of the part number 2. Now we go move the part B, go to the switch 0, go to the CLI and issue the show MAC address table. Okay, so this one is switch 0. Open this, go to the CLI, enable show MAC address table. Okay, we see 3 entries in this table. So that's will be the yes. Okay, why are 2 MAC addresses associated with one port? Yeah, so we see we have 2 ports, F0/2 and F0/2, and we have only 2 MAC addresses. So 2 MAC addresses on the single port. Why? Because if we see the topology, so in this topology we can see that 2 laptops are connected with the access point, and this access point is connected to the one single port of the switch, and this one is the port number 2. So that's why we are receiving 2 MAC addresses on this single port from different 2 laptops. So the answer is because 2 devices are connected to the one port through using the access point. Okay, now if we go to the part number 3, examine the ARP process in the remote communication. So we have to generate the traffic first. Click on this computer .2 and open the command prompt. Okay, we will go to the number 2. Okay, into the ping command 10.10.1. Go to the command prompt 10.10.10.1. Okay, the next one is type ARP-A, and what is the IP address of the new ARP entry? So if we go here, okay, so we see this table, and the latest entry is at the top. So the IP address will be 31.1. This one. Okay, enter the ARP-D to create a table and switch to the simulation mode. So go back, type ARP, F1T. Okay, now we will switch to the simulation mode. Click on here. Okay, the next one is repeat the ping to the 10.10.10.1 and how many PDUs appear. So repeat the ping, same repeat 10.10.10.1. So I just type up arrow key to repeat the command. So hit enter. How many PDU? We see the one is the ARP, the other one is the ICMP. So we see 2 PDUs. So the answer will be true. The next one, the F point, click on the capture forward, click on the PDU that is now at the switch 1. So, and what is the target destination IP address? Okay, so we will move forward. Now we have to check the PDU at the switch 1, the target IP, the destination IP. So the destination IP, we can see the target This is the third destination IP. So 172.16.31.1 this destination IP. Okay, so the destination IP is not 10.10.10.1. Why? Okay, it's not 10.10.1 because we can check that these are two different networks. So the first network, the source network is 172, the destination is 10.10. Okay, so because these are two different networks, so to find the actual path, this source computer will be first send the ARP request to the gateway, and in this scenario, for this computer, the gateway is the router 1. So that's why the destination IP is not 1. So the destination IP for this packet will be the gateway of this router first. Okay, the next one, step number 2. Examine the ARP table on the router R1. So we will move to the real-time mode again, and we will go into the router R1, and we will go into the CLI mode. So go back to the packet trace activity, go to the real-time, go to the router 1, and on the router 1, CLI, and we will issue the command show trace table. Go to the CLI, enable show like trace table. We don't see any entries, there is the blank. So normally this trace table is used in the serial connections of the routers. So so this command is pretty different as compared to the switch command. So we don't see any entry because this command is completely different than the switch. So that's why we see the 0 entry in the router. Now show the ARP command on the router, and do you see any entry for .2IP? Let's try. So show ARP. Okay, we see two entries. The first entry is .1 and the second one is .2. So we see the entry for the .2IP. So the answer will be the yes. Okay, the next one is what happened to the first ping in the simulation mode. So normally the first ping is the timeout because on the first ping the device does search of the destination MAC address using that request. Okay, that's all. So this completes the activity. Thank you for watching.